Hi, my name is Tufa Dinku. I am a climate scientist at the International Research Institute for Climate and Society. I have over 20 years of experience in the area of climate science and its applications. I worked as a meteorologist in Africa for 12 years, and I have been with IRI for 8 years now. The main focus of my research at IRI is improving the availability, access, and the use of climate information. Today, I will share part of my work with you. Today's presentation will focus on how satellite data could be combined with station data to overcome data challenges. I will describe the main issues around availability of climate information, propose a solution, and then present examples on how these solutions have been implemented in Africa. Hi, my name is Tufa Dinku. I work at the International Research Institute for Climate and Society. Today, I'm going to talk to you about improved climate data for improved climate services, particularly in data-sparse parts of the world. Here is the outline of my talk. I will start by making a case for the critical role of climate information and climate services for climate resilient development. There is no climate service without climate data. Thus, I will talk about the challenges of data availability and access and how those problems might be addressed and some implementation examples. First, let's start by defining what climate services are. Here are two definitions looking at different aspects of climate services. The first one comes from the Global Framework for Climate Services from the World Meteorological Organization. This defines climate service as the provision of one or more climate products or advice to assist decision-making by individuals or organizations. Second definition from the National Oceanic and Atmospheric Administration of the US defines climate service as accessible and timely scientific data and information about climate that will help people to make informed decisions for their families, businesses, and communities. Climate resilient development is critical for managing negative impacts of climate and making the best of favorable climate conditions. And climate information is one of the critical inputs for climate resilient development. Climate information is provided mostly by climate services. Stronger climate services would be able to provide the right climate information at the right time and in the right format. Thus, stronger climate services are critical for effective climate-smart development strategies. Climate data is the foundation for all climate services. There is no climate service without climate data. Good quality climate service depends on quality climate data. Thus, strengthening climate services need to start with strengthening their capacity to collect, process, and disseminate climate data and information. Information on the past, present, and future climate is used in many different activities. The use of historical climate data include, among other things, putting observed and anticipated climate into context, assessing climate-related baseline risks, understanding the nature of climate variability and trends, understanding the impacts of climate on different socio-economic activities, developing and validating climate forecasts, producing different climate maps and atlas. On the other hand, current observations are used in many operational applications such as monitoring and early warning. Some of the monitoring applications may include floods and droughts, water levels in dams, soil moisture, crop and forest conditions, climate-sensitive diseases such as malaria and meningitis. Climate forecasts at different time scales are also used in many different applications. Daily to seasonal forecasts may be used for operational management, early warning, and long-term planning, while climate change projections may be used for investment planning and assessing impacts of climate change on different socio-economic activities. Now let's turn to challenges in the availability of climate observations. I have tried to underline the importance of climate data, and climate observations are the main source of climate data. There are a number of challenges to the availability, access, and the use of climate observations. The number of weather stations are not adequate, particularly over many parts of the developing world and remote areas. Most of the stations are located along main roads and in the cities. There are serious gaps in observations because of missing data. The quality of the data could be questionable. And finally, there's limited access and the use of the available data. The map on the top right shows stations reporting data on a daily basis. These are not the total number of stations, but just whose data is available globally. We can observe that there are not many reports from most of Africa and parts of South America. And there are limited data over most of the rural and remote areas. On the other hand, available stations might not mean available data, as some stations may not be reporting. The figure on the bottom left shows the situation. The red color in this map shows stations that were not reporting or silent during the 1998 to 2002. Again, this might not mean that all of the stations were not operating. Some could be operating but were not transmitting the data through WMO's global telecommunication system. The last graph on the bottom right shows a decline in the number of weather stations used in daily global historical climatology network GHCN starting from the 1960s. The decline still continues outside North America. These declines are also observed at the national level in many developing countries. Lack of availability and access to actual observations has led to creation of other climate data sources. These include grid station data, satellite estimates, and reanalysis products. The main strength of this data set is that they are freely available over most parts of the globe. However, they also suffer from serious shortcomings. Grid station data availability and quality depends on observations. Is available at coarse, spatial, and temporal resolution, not available over remote areas, and access requires internet and some skill. Satellite estimates, poor accuracy at higher resolution, limited climate variables, mostly rainfall and temperature, in many cases short time series, and again internet and some skill is needed to access and use this information. Reanalysis products have poor accuracy, coarse spatial resolutions, and again require access to internet and some skill to access and use this information. The quality of these products are different. This figure compares monthly observed rainfall in green, satellite estimate in orange, model reanalysis in red, and gridded station product in blue, averaged for a box over central Ethiopia. The gridded data is very close to station data because this product uses good number of stations from this part of Ethiopia. There are big differences between station measurements on one hand and satellite estimate and reanalysis products on the other. The reanalysis product is the least accurate. This is generally the case for many parts of the world. The INAT's approach to improving the availability, access, and the use of climate information. INAT, which stands for Enhancing National Climate Services, is IRI's effort to simultaneously improve the availability, access, and the use of climate information. It is presented here as an example on how to overcome the challenges described earlier. So, what can we do to tackle the challenges of data availability and access? One option would be expanding station network. Expanding station network is a good thing. However, this by itself may not be that helpful because this is an expensive endeavor, cannot cover everywhere, cannot solve the problem of historical data, and again may not be able to address the issue of access challenge. The other option might be to continue using satellite and other proxies, but this also has its own shortcomings. We have seen that the problem of accuracy, particularly at higher temporal and spatial resolutions. Satellite data offer limited climate variables, mainly rainfall and temperature, and access and use requires some expertise. The INAT's approach has two components: improving availability and improving access and use. Availability is improved by combining station measurements with satellite and other proxies. This will involve organizing and quality controlling of station data, combining the point measurements from stations with global spatial coverage of satellite and other proxies. This will help fill spatial and temporal gaps in observations, but may not solve all the problems. Improving access and use involves developing information products for specific applications, developing tools for data analysis and download, making information products and tools available to users, and engaging users in the development of information products. Here is an example for combining station observation and satellite data. The map on the left shows station measurements, which are assumed to be accurate but cover only part of the country. The middle map is satellite data. Satellite covers everywhere but is not accurate. In this case, for example, satellite underestimates rainfall over many parts of the country. The third picture on the right is a result of combining station data with satellite estimate. The combined product overcomes the lack of coverage by the station and the accuracy problem with satellite estimate. The INAT's approach was first implemented in Ethiopia. The main activities included training of national meteorological staff, data organization and quality control, processing over 30 years of raw satellite data, merging station measurements with satellite data, upgrading the Met services webpage, developing products and tools and making them available online, and finally training users. To improve access to information, products, and the tools, first, the Meet Agency's webpage was improved for better presentation of existing and new products. Then a climate analysis and applications map rooms was created. This map room consists of 3 different map rooms. Climate analysis to look at past climate, climate monitoring to follow the current season every 10 days, and climate forecast for better presentation of seasonal climate forecasts. INAT has also been implemented in some other countries in Africa. The work in Tanzania has been completed and products are now available online in English and Swahili. In West Africa, in collaboration with the Agri Center, the product covers 8 countries and is expected to be launched very soon. The work in Madagascar has been completed and the new services will be launched and made available to public next month. And finally, thank you for watching.
Hello, I'm Erica Allis, and I'm a Senior Staff Associate at the International Research Institute for Climate and Society at Columbia University in New York. In my presentation, I'm going to summarize what climate services are, why they are important, and highlight a few examples of sector-specific decision support tools. I'm also going to recap the data poverty issue, potential solutions to this challenge, and step through the prescriptive process for enhancing national climate services and development activities. In many impoverished regions of the world, droughts, floods, or even a delayed monsoon can wipe out years of development gains and push vulnerable communities further into poverty. As Tufa mentioned in the beginning of his webinar, using climate information in decision-making and planning can help reduce the negative impacts associated with certain climate events, and also make the best out of good years. Climate services involve the production, translation, transfer, and use of climate knowledge and information. Climate services enable climate resilient development. To better illustrate how climate services benefit development activities, I've highlighted a few of the development sectors, climate variables of interest per sector, and examples of decision support tools for each of these sectors in this slide. Tufa highlighted many of these in his webinar, although some of them are new. I'm not going to read through the text on the slide verbatim, so you may wish to pause the webinar to get a better feel for the climate information and tools and how these can enhance climate resilient decision making. It's important to note that the climate information of interest can differ among sectors, so there isn't really a perfect tool that fits every sector, and climate information and tools need to be tailored to really support decision making. As Tufa mentioned in his webinar, reliable and accurate climate services rely on good quality data. As shown in this figure, many of the most vulnerable regions of the world are data poor. Spatial gaps are a result of sparse station data. For example, many stations are located in cities and along the main roads, and not necessarily in rural communities. What is not really shown in this figure are the temporal gaps due to interrupted observations or lost data. One example of this is the civil war in Rwanda, which left the last 19 years with virtually no climate record. So if climate services are important for development, and climate services depend on high-quality data, what can you really do in regions that lack data? Well, thankfully, there are a few options available to solve the data poverty problem. You can install more monitoring stations, which is an important component, but does not solve the gap in historical data, and this information is required for meaningful climate analyses. You can use satellite information, which offers greater coverage, but when used by itself has poor accuracy and also offers limited climate variables. Reanalysis products can be used, although these have poor accuracy and coarse spatial resolution. Or you can take the ENACS approach that Tufa covered in his webinar. This essentially combines the first 2 options to result in a better product. It has been IRI's experience that merging station data with satellite data yields good results and is cost-effective. The merging of this information is one step in the Enhancing National Climate Services, or ENACS, process. As Tufa mentioned, ENACS has been demonstrated in Ethiopia and has further been replicated in Tanzania, West Africa, and Madagascar, so it's a scalable approach. This slide outlines the prescriptive process or sequence of recommended activities to deploy the ENACS process to address the data poverty issue. The first step is forging of partnerships between the National Met Agency, technical institutions, and the user community. The National Met Agency is a critical partner as they have the mandate for collecting climate data and developing climate information for users. Technical institutions are critical for capacity building throughout the process, and the user community should be engaged at the onset to best ensure the decision support tools meet their needs. A second important step is a QA/QC of the station data. Inhomogeneities in the dataset can skew climate analyses. These inconsistencies are common in many countries as rain gauges are often checked and recorded manually and later transcribed in a database. In this process, there are multiple opportunities for transcription errors. If there are questions on the data quality, it's probably a good idea to have a data quality workshop in which the technical institution and National Met Service work together to identify and correct data inhomogeneities. Once confident in the data set, the technical partner can work with the Met Service to calibrate satellite with station data and produce satellite rainfall estimates, and then combine the satellite estimates with the rain gauge data. Once you have the combined data set, there's a need for training activities to develop and use the data to tailor this information to meet the needs of decision makers. Now, Tufa mentioned the Ethiopia case study in his webinar. In this example, the IRI partnered with the Ethiopian National Meteorological Agency, or Ethiopia Met for short, the University of Reading, the World Health Organization, the National Ministry of Health in Ethiopia, and the Anti-Malaria Association. The goals of this partnership were to develop a merged satellite and observed climate dataset specifically calibrated over Ethiopia, to improve access to data by making it available on the Ethiopia Met website, and also to improve the use of climate information by users through capacity strengthening. The end product of this effort was a 30-year time series of rainfall and temperature data at 10-day periods for every 10-kilometer grid in Ethiopia. Map rooms were later developed on the IRI's data library platform to enable access to data. These map rooms were transferred to the Ethiopia Met website and are now available on their website, which was shown in Tufa's webinar. The health map room serves as an early warning from malaria and has been used with successful results to date. In this slide, I'm going to review some of the lessons learned through our experience in Ethiopia, Tanzania, West Africa, and Madagascar. First, it's been our experience that partnerships between the Met Service, technical institutions, and the user community are critical for success and project sustainability. Second, care should be taken in selecting a technical partner, as the goal of merging station and satellite data is to produce a high-quality data set. And if this is not achieved, the climate information feeding into the tools could be compromised. Third, data availability may not necessarily lead to data access, and good access may not necessarily guarantee effective use of climate information. Appropriate use requires knowledge within the user community of what is available and how it might be used to facilitate their decision-making. Projects should seek to facilitate dialogue between Met Service staff and the user community. And finally, capacity building in every link of the climate services chain is critical for project sustainability. We also recommend training on-site so that more staff can attend, as remote training has the risk that nominated delegates are not those responsible for the day-to-day activities, and this may not be taken back to the agency. And this concludes the Improved Climate Data for Improved Climate Services in Data Sparse Regions webinar. We really appreciate you watching, and we look forward to hearing from you.